Okay, so in this lesson, Spark in Parallel, we're going to be talking about one of the main benefits of Spark, which is essentially that it's fast. And as you probably can guess, this really becomes an issue when we're working with large data sets. When you're working with large data sets, a task that you may think is pretty simple, like say, trying to find a movie that was released in a certain year, can really take a while to accomplish, meaning several minutes. And it just makes it hard to program when every line of code that you write takes several minutes to accomplish. So Spark is designed to allow us to really query our data sets a lot faster. And in this lesson, we'll see how. So again, this is kind of how we load our data into the Spark cluster. And we do that through starting with S3. And then what we do, there's really these two different kinds of machines. So every gray rectangle here is, you can think of as a different computer. It doesn't have to be, but lots of times it is in a Spark cluster. And you can see that we're directly reading data into the driver. So that's one kind of computer. And this is how we directly interact with our Spark cluster, is through this driver machine where the Spark context is located. But really, the type of machine that's doing a lot of work, and when I say machine, what I mean is computer. So the machine that's doing a lot of the work are these worker nodes, okay? Node, again, just a computer. So these worker nodes is where, if you query the data, that's happening on these worker nodes. And you can see what's happening is we start with an entire list of data, right? All these movies. We read it into the driver through this Spark context. That's kind of like the software. And it gets distributed. This data set is spread across these three different nodes. So this node has a portion of the data, this node has a portion of the data, this node has a portion of the data. The reason why this can really be valuable and can speed up our queries is because, say we look for something like a movie like The Dark Knight. In Postgres, we would have to go through every single record one by one. But in Pyspark, because our data is split up, and the word for that is partitioned, because our data is partitioned, we can perform the query across each third of the data set simultaneously. And once we find that film Dark Knight, we can return it. And what becomes even more valuable, or really the way that this works, is because each node right here, each of the worker nodes, the data is stored in memory and it's processed with the CPU. Remember that with the CPU, what really matters is the number of cores. Why? Because if there's 4 cores on a CPU, then that means we can operate 4 tasks in parallel. Okay? So what does that mean for us? That means we can actually partition our data for once per each CPU. And that means that we can then query that data across each of those partitions simultaneously. Now you'll see this time in this diagram, I'm calling this an executor, right? Whereas previously I referred to it as a worker node. Those terms are essentially synonymous. The difference is a worker node refers to the computer itself, like the hardware, whereas executor is the software on that computer. So lots of times you'll hear people say like driver and executors instead of driver and worker nodes. But they're pretty much interchangeable terms. So you can see that, one thing that really determines how quickly we can query a data set is the number of the number of cores across our entire cluster of worker nodes. So if there are, say, 12 cores across all worker nodes, and that means we can split our data into 12 partitions. And so when we then say look for the movie The Dark Knight, we're now doing that in parallel across each 12th of our data set, speeding things up a lot for us. So this is one thing that can really affect the speed of our queries, is the amount of cores across our worker nodes. Another thing that can ultimately affect your speed of your queries is the amount of memory. So when you perform queries, like let's say you want to find all the movies that start with the letter M, some of the results may need to be stored in working memory to hold on to those results. But also remember that we're storing our data set itself in memory. So if we take up too much space in the storage component, we can leave potentially too little for actually performing the queries. That's just something to be aware of. By default, there's a 50-50 split. Spark will allocate 50% of the memory in an executor to working memory for the queries, and the other half for storage. And then finally, one thing I should say is that there is a name that they give to this partition data set. So we can think of, even though this is split into a separate partition per core across our executors, when you're operating on the data set, you think of it all together generally. You don't think of these different partitions when you're performing a query. And you can call that distributed data set a resilient distributed data set. So this refers to a data set that is partitioned. Okay? So let's see that. Let's actually interact with a resilient distributed data set. And because it's a mouthful, you'll hear this referred to as an RDD. Okay, so we can see this in action. The way I do this is by installing Pyspark on your local computer. If you try to just install Pyspark, it will involve more than just that. However, in these labs, you just have to press Shift Return through the steps and you'll be good to go. Then the next thing is, you can see I'm setting up, this is Spark configuration, and I'm setting the name. It's called the app name, but you can think of it almost like the name of a database. Now set master is, where is the driver located? Okay. Now this driver oftentimes will be on like AWS somewhere, and you access it through an IP address. In this case, it's local, so we put local here. If it had a URL, we would put that URL here. Okay, so this is the location of our cluster. Then finally, this square bracket 2, this is saying how many cores are we allocating to our application. So remember, this is really important because the more cores we allocate, the more partitions of our data, and that will speed things up for us. If you want to say allocate all available cores, you can just put a star here, but we'll specify too. Then finally in this step, we are saying, okay, we're going to now have our Spark context. We will get or create a Spark context and pass through this configuration. Okay, we'll talk about the Spark UI in a little bit, but now let's work with a data set inside Spark. So if we just, we can start with just some normal Python. So let's maybe say we have a list of movies. That will be Dunkirk. That will be, what are some movies? Dark Knight. And let's say Pulp Fiction. Now this is just a Python list, but we can go with our Spark context and read this in to our cluster by doing sc.parallel. I don't know if I'll be able to spell this right. Parallelize. Nope, can't spell it. Let me cheat. There you go. And then read in a list of movies. Okay? Now this is an RDD. All right? You can see it says parallel collection RDD. 2 is the number of partitions. And so let's call this RDD. And then if I ever query this data, I can do rdd.filter, and let's say I want to look for the movie Pulp Fiction. So I'll say lambda movie, calling the filter command, and for each movie, see does the movie equal Pulp Fiction. And then finally, we do need to call one other thing, .collect. That's it. I forgot. And now this will show us the results. So you see that? It went through each movie. It looked for Pulp Fiction. But because we're doing this in Spark, and it's in a RDD that's partitioned twice, it's actually performing that query across one partition and another partition simultaneously. And if this was a lot larger data set, right, this would really help us and really speed things up. One thing to point out is you can interact and play around with Spark in these notebooks. So, I recommend clicking on this and taking a look. One thing that's really cool about interacting with Spark is you can really get to learn more about it through the Spark UI. So the Spark UI kind of lets you see what's going on under the hood in your cluster. So I'm going to click on Spark UI, and you can see, last time it'll take you to something like this. Let's take a look at executors for now. So what you can see is that we have allocated these 2 cores here. So we'll learn more and interact more with the Spark UI, but I just wanted to show you that the concepts that we're learning about are reflected in our Spark UI.